or continuous delivery, right? Yeah. So how can we integrate all the tools with Jenkins? How can we deploy the application? How developers start the development? Okay. How can we convert to the Maven project? Maven project. Very good. What can you come again? Maven? Maven. When I creating jobs in a good project in job, that time I'm failure getting job is not success. You're saying, right? In Jenkins, when you run some jobs, right? In Jenkins, those are success or not success. But when you try to pull the code from GitHub to Jenkins, Maven project. We'll discuss. Okay, wait. Java environment is not set to like this. Java environment variables. Oh, no. Whatever the code I provided, HTML, you tried that or other one? Other one. Okay. So if any errors are, if any errors are or any fixes are in the code, it will not be executed. That you need to check it out. But I fix it from not XML other like all files. What's magic? But getting error into. You can show me. Okay. You can show me the code. Definitely check it out. Okay. So maybe the issues with the code. Okay. You can try any code, but the code should be in proper manner, and also form.xml should be required. Yes, form.xml required, and also that code should be in structured way. Then only, we can easily deploy. Okay. Yeah. Any other questions, anyone? So make sure everyone practice the project, which is a very, very important project. So most of the organizations, they're using the CI/CD in Agile methodology, right? Today we'll start Docker. Docker is a core tool, advanced tool, right? Right. So what is Docker? Why the Docker is very popular now? Why the project teams are using Docker containers? Okay, these are all we discussed today. Yeah. So what is Docker, anyone? Docker is a container tool. Docker is a container tool. What is container, anyone? What is container? Container is a standard unit of software. Standard unit of software, right? Yeah. So container in general, what is container? Container is a box. We can move anywhere. We can use anywhere, right? We can store anything on the container. So container is a box. It is not a virtual server, right? So containers are advanced to virtual servers. Containers are advanced to virtual server. So what is virtual server, anyone? Which is not a physical, which is a imaginary server, right? So containers are advanced to virtual servers. Right? Now let us go and discuss about few important things here. So let's Sublime. We can use Sublime here. Sublime. Docker is a container tool. Container is a standard unit of software. Yeah. Standard unit of software. It's a lightweight, standalone, and executable program. Lightweight and standalone. Okay, fine. Now let us go and discuss about a few examples here. For example, let us take server, right? So on the server can be any physical or virtual server. So if you want to deploy operating system, OS, to deploy operating system, install OS, operating system. So we required ISO image. We need ISO image. What is ISO anyone? International Standardization Organization. To install OS, we need ISO image, right? So what is ISO? International Standardization Organization, right? ISO is the full blowing operating system. Normally, server side ISO image would be minimum 8 GB to 8 GB to 18 GB. ISO image size would be minimum 8 GB to 18 GB, right? So if you take Amazon Linux, minimum 8 GB required, right? To take Windows 2022, minimum 18 GB required, right? So ISO image size would be 8 GB to 18 GB, right? And also, when you want to reboot or restart server, it takes 4 to 8 minutes. So when you want to restart any server, physical or virtual server, it takes 4 to 8 minutes, right? So normally laptops and desktops we can quickly restart, but this server side, it can be virtual or physical, any server. It takes 4 to 8 minutes because once we restart, it will check the memory, processing, patches, updates, everything it will check. So slowly it will restart, right? But desktop and laptop, you can restart within 1 minute. But server side, it takes minimum 4 to 8 minutes. Slowly, it will stop all the services. It will start all the services slowly one by one, right? And also, deployment time and downtime is high. So in server, normally deploy, when you want to deploy any applications, deployment, okay, it takes some time. So downtime is also higher. Downtime, what's downtime, anyone? Downtime is a maintenance time, right? So deployment time and downtime is high, and restart time is minimum 4 to 8 minutes. And also image size, highest image size 8 GB to 18 GB, right? Yeah. So normally, for example, we deployed a Flipkart application on a server. So when we restart the server, it is taking 8 minutes. So client will not accept that much of time, right? 8 minutes is it's a yeah very normally 1 or 2 minutes also client will not accept for the downtime. But here the servers when we restart minimum it takes 4 to 8 minutes, right? Yeah, these are all drawbacks. Now, whereas container, container. So when you want to install OS, to install OS, right? So we don't use ISO image, we use Docker image. The Docker image size would be 200 MB only. Docker image size would be 200 MB only. So why that much of drastic change? ISO image size is 8 GB to 18 GB, but Docker image size is 200 MB only, not even 1 GB, right? Why that much of drastic change? Because here, when we install operating system, when we install operating system, only lib and bin files will be installed. Lib and bin library and binary files will be installed in the container, right? So containers are lightweight, standalone, executable program. We can move anywhere, we can use anywhere, right? Yeah, and also when you restart container, it takes 15 seconds only. Restart time, 15 seconds only. And also deployment time and downtime is very less. These are all advantages of container. So we are using servers currently, but why the project teams are migrating their applications to containers? Because so here the ISV size would be 200 MB. Only lib and bin files will be deployed on the container. It is lightweight, standalone, very faster. When you restart, it takes 15 seconds only, and deployment time and downtime is very less. These are all advantages. These are all advantages. Okay. Yeah. So currently, every project team, they're migrating their applications to Docker containers because of, yeah. Moreover, licensing cost is very less. Here, license cost. Compare with physical environments, license cost is less, right? Yeah. So these are all advantages of containers, right? Now, next one, let's go and discuss about high level application architecture. High level application architecture. Yeah. So any application. So when they want to prepare, so for example, development team, yeah, they are developing the application. So any application required three components here. Any application required three components. First one is front end. Second one is back end. Third one is database. Any application required three major components, which are front end, back end, database. So normally front end. So developers, they work on front end. Front end, what is front end? User interface. UI development, right? UI development, right? So for UI development, so developers, they use a HTML, CSS, JavaScript, yeah, etc. Right? CSS, HTML, JavaScript, etc. Right? Yeah. So by yeah, for to develop the this user interface, normally user interface is when you open any application. So when we open any Flipkart or Amazon Shopping Center or Myntra, so the first page when you open the page, which is a UI, right? User interface. So normally developers always use the most of the projects they're using HTML for the front end. Okay. Yeah. So back end is the API development. Backend is the API development. So to develop the backend application, so what are the technologies they are using? Java, Spring, Java Spring, Python, .NET, and Ruby, etc. Right? So backend is the API development. So backend, what is backend? For example, any application is having three components we discussed, right? So this is the front end. This is the front end, right? Yeah, backend. For example, these are the microservices. These are all microservices. Okay, so here different microservices are available. So if you want to update that microservice, we require API development backend, right? For example, here we have yeah. So these are the home records, right? So here, if you want to update any product pricing, or if you want to update any product images, or if you want to update any product offers, right, out of stock. So anything. So when we want to update, so backend API development required here. So backend developers, they modify the code. They update the code, right? Yeah. And also third one, which is a database, right? So what is database? Why we require database? Normally, for example, when you want to create your profile, right? So where the profile will be saved? The database, local database, right? So when we talk about database, so here different databases are available. MySQL database, Oracle database, MongoDB, Cassandra, right? Cassandra, DocumentDB, and so many DBs are available. Okay. Yeah. So every application required database also to store the profiles, to store the data, to store the product information, right? So database required. Fine. Now, so every application, when you want to run any application, all the services should run. For example, if you want to run any application like Jenkins, so if you want to run the Jenkins or any other application, all the services should run. If any one service is down, application will be down, right? One service is down, application will be down, right? For example, if I want to run my OS on my laptop, so I'm using OS, right? I'm using OS in my laptop. Yeah, look at this, everyone. If I want to run operating system on my laptop, Windows operating system, these are all services should run. Win services. Start with Win. If one service is down, Windows will not Windows will not work properly, right? Windows will, yeah, sometimes reboots, sometimes, right, hanging issues. Sometimes OS will not work properly, right? So slowness issues. We'll get so many issues. So these are all the Windows services, right? So all the services should run properly. Otherwise, Windows will not run, right? So why we are discussing about this? Because here we have a application style. So here in application style, we have two types of applications that are available. First one is tightly coupled. Second one is loosely coupled. So tightly coupled, loosely coupled. Two types of applications are available here. Okay, what is tightly coupled? What is loosely coupled? Let's try to understand here. So tightly coupled. So all the services should run properly. If any one service is down, if any one service is down, entire application will be down. If any one service is down, entire application will be down, which is tightly coupled. So all services should run properly, right? If any one service, so for example, as we discussed, Windows services, right? In case one service is down, voice will not run properly, right? Yeah. Whereas loosely coupled, all the services will run individually. If any one service is down, if one service is down, application will not be down, right? Yeah. So here, loosely coupled, tightly coupled. Tightly coupled, all the services should run properly, right? But whereas loosely coupled, so all the services run individual, right? One service will not depend on other service, right? So when one service is down, application will not be down. So why we are discussing about this? Because Docker implemented in loosely coupled. In case one service is down, application will not be down, right? So in Docker, we are using microservices. All are microservices. In case one service is down, nothing will be happening, But whereas tightly coupled in Jenkins, for example, Jenkins developed in tightly coupled. So in case one service is down in Jenkins, Jenkins will be down, entire Jenkins will be down, right? But loosely coupled is not like that. So in case one service is down, nothing will be happened here. Okay. So that is loosely coupled, right? Next one. Before Docker, before Docker, we used to use containers. What are those? So before Docker also we used to use the containers. What are those? Okay. So Docker is not, container concept is not new concept. Container concept is not new concept. Before Docker also we used to use some containers, old containers. What are those? First one is LXC. Second one is Jones. Third one is LMCI FI. Before Docker, we used to use very old containers. These are the LXC, Jones, LMCI FI. What is LXC? LXC is a Linux container. Jones is the Solaris container. LMCI FI is the Google container. LMCI FI full form is let me container for you. LMCI FI full form is let me container for you. Right? So LXC, Jones, LMCI FI. Three different types of containers we used to use before Docker. So currently Docker is very popular. So before Docker, we used to use all these containers. But these containers are failed. These containers are failed. Why these containers are failed? Because these containers are platform dependent containers. These containers are platform dependent containers. What is platform dependent anyone? Only one platform can. What is platform dependent anyone online? These containers are platform dependent containers. So here LXC run on Linux only. LXC run on Linux only, right? Jones run on Solaris only. LMCI FI run on so these containers run on their respective platforms. Okay. So LXC will not run on Windows. Jones will not run on Linux, right? LMCI FI, it will not run on Linux, right? So different, yeah, these are the platform dependent containers. So their respective platforms only we can run these containers. That is why these containers are failed. We are not using currently. Yeah, so these containers are failed currently. Right? Failed containers. Failed. So why the Docker is very popular? Why the Docker is very popular? Why the Docker is very popular now? Because here Docker we can run irrespective of operating system. We can run Docker on Linux, Windows, Solaris, even Mac OS also. Mac OS also. So we can run Docker containers on, we can run Docker containers on any platform, Linux, Windows, Solaris, Mac OS, right? So yeah, so these containers are lightweight standalone, right? We can run on any OS, we can move anywhere, we can use anywhere. That is why these containers are, Docker containers are very popular. Docker containers are very popular. So currently, most of the project teams, they're using Docker containers. Clear, right, everyone? Up here it is clear, right? Yeah. So before going to install configure Docker, before run the containers, first we need to understand all the theoretical part here. So which is very important in interview questions also, right? So interviewer asks you, before Docker, we used to use some containers. What are those? Before Docker, LXC, Jones, LMCI, F5, right? Before Docker, we used to use. So currently, Docker is very popular. Why the Docker is very popular now? Docker is, Docker is, we can say, platform independent. Docker is platform independent containers. These containers are platform independent. Okay. So here, platform dependent. Platform dependent. These are the platform dependent containers. Here, platform dependent, independent containers. So that is why Docker is very popular. Platform independent means so we can run on any platform, right? Not only Linux, not only Windows, not only Solaris. So we can run on any platform. That is why currently Docker containers are very popular. Most of the projects they're using Docker containers. Clear, right, everyone? Yeah. Next one, Docker editions. Docker editions. What are the editions available in Docker? First one is community edition. Second one is enterprise edition. Community edition, enterprise edition. Two editions are available. So what is community edition? What is enterprise edition? So community edition is freeware, no license. Okay, it is free. We can use the community edition in our practice classes. Okay. So enterprise edition is it is a license. It is not. Yeah, in real-time projects we use the enterprise edition. Clear it everything? Community edition and also enterprise edition. Now let's go and discuss about the Docker architecture. Now go and discuss about the architecture, how the architecture would be, Docker architecture. Yeah, so this is very good information. I'll share with you this whatever we discussed now. Okay. So interview questions also here, basic interview questions. Next one. Docker architecture. So before discussing about Docker architecture, let's try to understand virtual server architecture first. Before going to discuss about this, let's try to understand virtual server architecture, virtualization. Virtual server architecture. Let's try to understand virtual server architecture. In virtualization, in virtualization, what is virtual? Anyone? What is virtual? Anyone having idea? What is virtualization or virtual? Anyone online? What is virtual or virtualization? Anyone? Virtual is a which is not a physical, right? So virtual, imaginary, imaginary. We can access virtually. We can take virtually. We can connect virtually, which is not physical, right? Yeah. So imaginary. Fine. Now, for example, here we have a server, which is we can say this is a base OS, base operating system, base OS. Okay. Yeah. So which is a physical server, which can be physical server. So we can take one physical server, high capacity server. So on top of that, what we will do, we can deploy a software which is VMware or hypervisor or Citrix. So we can prepare a server which is physical server, yeah, which can have a high CPU, high memory, for example, RAM, here 48 GB, CPU 32 core, 32 core, and also storage, storage 20 TB, like this. Highest capacity, highest capacity. Okay. So we'll take one highest capacity of the server. On top of that, we deploy the software which is VMware, hypervisor, Citrix. This is virtual software, right? So VMware is a virtual software, hypervisor, and Citrix also virtual softwares. Once we deploy the software, what will happen? This software will allow you to create virtual servers. These are all virtual servers. Look at this one. These are all virtual servers, right? So 5 into 5, 25 servers. As per your physical server capacity, we can create the virtual servers. So here we can deploy different operating systems here. In this virtual servers, we can deploy different operating systems like here Windows 2022, RHCL, Red Hat Enterprise Linux, SUSE Linux, SUSE, and Ubuntu, and also here Windows 2025 data center edition. Like these different operating systems you can deploy, right? So these are all virtual servers. 5 into 5, 25 servers we created on top of the physical server, right? Yeah, so that is fine. But here, so when you want to deploy operating system on a server, what do we require? So I want to install operating system on a server. What do we required here? We required yeah, ISO image. So these are the 25 servers, right? 5 into 5. So 25 servers, yeah, normally 25 servers required OS, right? Operating system. So if you want to deploy operating system, we require ISO image. What is ISO image? For example, in your laptop, if you want to install Windows, how can we install anymore? In my laptop, I want to install Windows, for example. How can we install Windows on the laptop? We require image, right? Yeah. So that image we can copy into pen drive. That pen drive we can configure as a bootable drive. By using the pen drive, we can boot the laptop or desktop, and we can start the installation, right? That is the process, actual process, right? So here in cloud side and physical server side also, we use one image which is a ISO image. By using this, we can install configure the operating system, right? So this ISO image size would be minimum 8 GB to 18 GB, right? So here we have 25 servers, 5 into 5. So each server can occupy 10 GB, for example, 10 GB. 10 into 25. How much? 250 GB. 10 into 25, which is 250 GB, right? Yeah. So we need to spend 250 GB for only operating system. Operating system. So on top of that, again, we need to install Java, Git, Maven, Python, whatever we require. That takes more space. So everyone following, right? Online students, everyone following, right? So OS image size minimum 10 GB, on an average 10 GB for each server, 10 into 25 servers. Here we have. So which is a 250 GB for 25 servers we need to spend. So only for operating system, we need to spend 250 GB here. So on top of that, again, we need to install all the applications, patches, plugins. That takes more space, right? So storage costing is very high. This is one of the drawback. Okay. And also, when we want to restart server, it takes 4 to 8 minutes. So when you want to restart the server, it takes 4 to 8 minutes. So normally 4 to 8 minutes client will not accept. Okay. If the server is down for 8 minutes, for example, Flipkart is down for 8 minutes, what will happen? Business will be, client business will be impacted, right? The Flipkart is down for 8 minutes, application will not be accessible. Yeah, business will be impacted. That is why client will not accept. This is also one of the drawback, right? And also deployment time and downtime is high. When you want to deploy any applications on a virtual server or physical server, it takes more time, right? We need to follow the step by step. We need to execute the commands. We need to run the commands. We need to wait for some time to deploy the application, right? That takes more time, right? And downtime is the maintenance time. When you want to down, like when you want to restart, when you want to shut down, right? Yeah, downtime deployment time is higher. Moreover, license cost, OS license, application license, right? Every license cost is higher. High. Costing is very higher, right? These are all drawbacks. Still, we are using virtual servers, but these are all drawbacks. Online students, everyone following, right? So that is why every project team, they're migrating their applications to containers, right? So Docker containers. Now let's try to understand Docker architecture. Now let's try to understand Docker architecture. So this is virtual server architecture, virtualization architecture, right? Now, yeah, in Docker architecture, so we need to take one server here. In Docker architecture, we can take a server here, which can be cloud server, which can be cloud server, ASOS, which is AWS EC2 instance. Okay. Yeah. So on top of this, what we will do? We prepare a image which is Docker image, right? So here we deployed the virtual software, but here we deploy the Docker image. Once we deploy this Docker image, this will allow you to create containers. These are the containers, right? So here we can deploy the operating environment. Here we can deploy Ubuntu, RHCL, Red Hat Enterprise Linux. Here is SUSE Linux. Here Windows, like this, right? So when we run the container, so in the containers, when we run the containers, only lib and bin files will be created. In the containers library, binary files will be created, right? Lib and bin. Yeah, so lib and bin is lightweight, so very less size. Okay, so here we use the to run the operating system, to deploy the operating system. So we use Docker image here, Docker image here. The Docker image size would be 200 MB only. 200 MB only. Docker image size would be 200 MB only, right? So when you want to restart time, 15 seconds only. Restart time, container restart time, right? And also deployment time and downtime is very less. Yeah. Next one, license cost is less, right? So these are all advantages of Docker containers. That is why most of the project teams are using Docker containers. Okay, most of the companies, they're migrating their applications to Docker containers. Clear, right, everyone? Any questions here, anyone? Anyone having any questions here? You understand the difference right here? Client always look for the cost saving, time saving, right? So that is why here, this is a bit costlier compared with Docker. And also, Docker is very faster. Virtualization is bit slow. That is why every organization they're migrating their applications to Docker containers. Any questions on anyone? Shall we go and install configure Docker? Online students, any questions you can ask me. Okay. How many servers required? Docker server, one server, cloud server. On top of that, we can run the containers. Like Jenkins installed. Yes. Yeah. You can create one server or number of servers you can use in real-time projects. So, but on a single server also you can run number of containers. Any questions here? You can go to port numbers you can assign. I'll show you how to assign the port numbers. Okay. Yeah. Now, let us go and install configure Docker. After that, we can run the containers. Okay. How to run the containers, I'll show you. So here, yeah, how can we install let's try to understand. So Docker installation is very important installation. Will real-time projects try to understand. Docker installation steps to follow. First one is create a Ubuntu server 22.04 is the stable version. Create an Ubuntu server, create an Ubuntu server with the 22.04 version. After that, second step here is create a user. Create user. So why we require user here? Why we require user? Create user. So why we require user? Yeah. So normally in real-time projects, we don't use root yet, root account. Root will be disabled in real-time projects. That is why. So always we use user account. Okay. Yeah. Create user and add password to the user. Create user and add password to the user. Third step here is modify SSHD config file. Modify SSHD config file. So SSHD config file should be modified. What is the configuration file here? I'll show you. Yeah, slash etc slash ssh slash sshd underscore config. This configuration file we need to modify. So in this file, password authentication by default it would be no. That we need to modify. How to modify? I'll show you. Okay. So after that, next step, fourth step here is once we modify, we need to restart the service. Service should be restarted. Restart SSHD service. Restart SSHD service. Fifth step here is give full permissions to user. We need to give full permissions to the user. How can we give full permissions to the user? How can we give permissions to the user? Where we can apply the permissions? Anyone? vi slash etc slash sudo words. Right, in this file, we need to apply the full permissions. After that, sixth step here is sixth step. We need to add that user into Docker group. We need to add the user into Docker group. So we need to add the user into Docker group, right? So once we add the user into Docker group, seventh step here is next step. Create Docker Hub account. Create a Docker Hub account. What is Docker Hub account? We have GitHub account, right? In Git, same way Docker Hub account also required, right? Yeah. So Docker Hub account, why we require Docker Hub account? So whatever the containers we run, that containers we can push to the Docker Hub account. So from Docker Hub account, if any developers, testers require the containers, they can pull it to the local, they can run it as a container. They can work on the containers, right? So once we create the Docker Hub account, yeah, next step here is create containers and push the containers to the right. So these are the steps we need to follow. Create open. Okay. Here one step is missing, which is a very important step. Install and configure Docker. After that, third step is create Docker account, modify SSD config file, and restart SSD service. After that, give informations to the user and add user to the Docker group and Docker Hub account required. Create Docker Hub account. Ninth step is create container and run container. Push the containers to Docker Hub account. Right. So these are the steps we need to follow. Now let us go and work on this first. Okay, quickly we can go and start this. Yeah. So now, first of all, we require one Ubuntu server, right? We can take one Ubuntu server, go to AWS account, go to EC2 instances, launch instance, Docker server, take Ubuntu, second AMI, to micro, here, keep here, network settings, GB, storage, for instance, launch instance. On these you can use separately available. Which one? You said when all series. Alt is. We can use alt is. Other ones. Other one also we can use, but alt is would be better. So particularly you can use this. Particular port number you are saying, right? Options. Or it is a security groups options. Alt is would be better because we need some port numbers should be enabled. Alt is would be better. Okay. So if you use only SSH port number, again it will ask you to enable the port numbers. Better you can use the alt is. Yeah, now the server is in running state. Now I want to connect this server, copy the public IP, open the mobile exchange, SSH, paste here, IP address, username, and give the key pair. Right. So these are the commands. We can go and execute all the commands. Look at the second one. Docker installation commands. So 8 commands we have. Those 8 commands we can execute one by one. Look at this one. First, we need to update Intel repository. And, so package here, download the package. So add repository, and again we can update and apt catch policy also we need to perform. After that, we can install the Docker by using this command, main command. After that, we can check the Docker status. Docker is running properly or not. We can check the Docker status. Okay. So these are all commands. Okay. let us go with one by one. All the commands we can execute. One by one we can execute. First we can update. Once we update, after that we can execute the apt transport command. Copy this, paste here. Yes. Yeah. After that, tell command to get the package. After that, the fourth one, add repository. Enter. Next command. Update again. Next command. Now this is the main command to install Docker. This. Now the Docker is installed. Give yes. Docker is installed. So once Docker is installed, we can check whether the Docker is running properly or not. Status we can check here. Look at this. Now it is in active state and running state. Docker is in active state and also in running state. Right. Control C 2 times. Once the Docker is installed successfully, after that, next step, what is the next step here? Create user. Why will you create a user? From the, yeah, perform the activities. Okay. Yeah. How can we create the user? What are the command to create the user? What are the command we use? How can we create the user? Anyone? Online? Yeah, online. What are the command to create the user? Anyone? In real-time projects, we segregate the port numbers. We don't use the RDCP. Yeah, we segregate the port numbers. So how can we create the user? How can we create the user? What are the command we use? Add user, right? Add user or user add. The command here is add user or user add to create the user. User add space user name. Enter. Sorry. So now we require a sudo. Sudo, always you need to apply the sudo. Sudo user add space user. Now user is created here. User is created here. Once we create the user, I want to add the password. Sudo password PASSWD space username. Now it is asking new password. Use the new password, retype password. Now password is updated successfully. Once password is updated successfully, we need to modify the SSHD config file, right? So sudo vi slash etc slash ssh slash sshd underscore config. You need to go to this path, open this. Now password authentication should be yes. By default, it is no. We need to modify into yes. Look at this, everyone. Password authentication is by default, it is disabled. Yeah, commented. If you give hash, this is commented. Commented means disabled. This should be enabled. Remove the hash. Now it is enabled. Okay. Escape, save and quit. Enter. Now the file is saved. Once we save this file, after that, we need to restart the service, right? Once we modify the configuration file, make sure the service should be restarted, not server. Service should be restarted. How can we restart the service? Sudo service sshd restart. Now the service restarted. Once we restart the service, we need to give full permissions to the user, whatever the user we created here. That user required full permissions. How can we give the full permissions? Command here is sudo vi slash etc slash sudowords. Sudowords. Right? Now go down here. Root is having full permissions. Look at this, everyone. Root is having full permissions. Same permissions I want to apply to the user. How can we apply YY and paste? Now I copy pasted here. Insert, remove this user and give the Rama user, whatever user we created. So once we modify this, once we copy paste the line and once we modify the user, once we save this, what will happen? Whatever permissions we apply to the user, whatever the permissions are available with the root, that will be reflected to the user also here. Understanding, right? So whatever the permissions are available with the root, those will be reflected to the user also. Escape, save and quit. Normally it will not be saved. How can we save? This file, yeah, normally when you want to save the file by using shift colon W, it will not be saved. How can we save? Shift colon WQ, escalator mode, forcefully. Now it is saved. Once we save this, next step, what is the next step here? Add user to the Docker group. How can we add user to the Docker group? So the command here is chmod. Chmod is the change mod. We can add into the Docker group. How can we add? So here sudo chmod space chmod hyphen a capital G. Hyphen a is the option, capital G is the group, right? Space group name Docker space user, right? Sudo chmod. We can use not chmod, user mod. We can give user mod. Permission. Yes, yes. Okay. Chmod is the permission, right? User mod. We need to give the user mod. Hyphen A, capital G, and group name and user. Enter. Now the user is added to the Docker group. So if the user is added to the Docker group or not, how can we check? Sure. First of all, we need to switch to the user here. We created the user, right? We created the user, right? That user we need to switch. How can we switch? SU username. Now give the password. Now here you can give bash. Now I switch to user, right? Once we switch to user, after that we need to check the user is added to the Docker group or not. How can we check? ID space hyphen M capital G. The command here is to check the user is added added to the Docker group or not. If you want to check ID space hyphen N capital G. Now this user is added to the Docker group. Understanding right, everyone? Yeah. So now Docker is configured properly, right? So if the Docker is configured properly or not, if you want to check, just execute here, command Docker, just Docker, enter. It should show all the Docker commands. When you execute Docker, when you give Docker and enter, it will show you the all commands. So if all the commands are available, Docker is configured properly. Enter. Look at this. These are all commands. Docker is configured properly. Clear, right? Docker is ready. Next one. Next, what we require here? Docker account should be created. Docker account, Docker Hub account. Docker Hub account required. GitHub account we created, right? In Git. Same way in Docker, we require Docker Hub account. How can we create the Docker Hub account? So how can we check the Docker Hub account? Let's try to understand it. Hub.docker.com. To create the Docker Hub account, we will go to the hub.docker.com. So look at this, everyone. These are all repositories available. Now, sign out here. First time when you give hub.docker.com, look at this. It will show you like this. First step, right? Click on sign up. Click on sign up. Now it is asking you to give the work email, username, password, right? Will ask you. So you can use the Gmail, Google account credentials you can use here, or else GitHub account also you can use here. Or else you can sign up a new account also. Okay. Work email. So if it is personal account, give the email address, username, password. Okay. And you can check the checkbox, click on sign up. It is very simple, very easier. To create the account, it is very simple, very easier, which is free of cost. No charges, nothing. Okay. Once we sign up this account, again, we can go to the up.docker.com, click on sign in. Sign. Yeah, give the email address, password, click on continue. Now we are able to log in into the Docker account. These are all repositories available. These are all repositories, different repositories. Clear, right, everyone? Everyone clear, right? How to set up Docker? How can we set up the Docker Hub account? You understand that, everyone? Any questions, anyone? Yeah. Containers we can run tomorrow. Containers we can run tomorrow. Containers, how to run the container? How can you deploy the applications on the container? How can we move the container to Docker Hub? We'll discuss tomorrow, right? Because that is a very core concept, important concept. Okay, that will take some time. So meanwhile, everyone prepare your Docker server today. Today you can install configure Docker. I share with you these commands in the Google Classroom. You can check these commands and you can install configure Docker and you can create the Docker Hub account also today. So tomorrow we'll run the containers and we can push the containers to Docker Hub account. Clear, right, everyone? Any questions, anyone here? So we can stop here. make sure everyone set up this Docker, and everyone create the Docker Hub account also. So tomorrow we'll start working on the containers. How to run the containers? How can we check the containers? How can we deploy applications on the containers? How can we manage the containers? So what are the real-time challenges? Right? I'll show you tomorrow. Fine. So we can stop here. Make sure everyone set up this Docker. So tomorrow we'll start working on the activities. Fine. Yeah. Thank you all.